So let's continue. Okay. All right, so guys, now we still have 2 exercises. In fact, I'm not going to go over exercise 1 because it is also a uniformly accelerated motion and it has the same concept as the previous example, but I have only to go over the unit here. So the unit here are US units, which means the position should be in feet, acceleration should be in feet per second squared, the velocity should be in feet per second. And in this case, guys, what you have to know, if I have a gravity, or if A is equal to gravity, then the gravity will no longer be 9.81, all right, like the case of SI units. In this case, in the case of US units, the gravity will be 32.4 feet per second squared, all right? So this is the only difference. Go to the next problem because this one, guys, is very important. It's a very important problem that covers both special cases. It covers the uniform motion and it covers the uniformly accelerated motion. And it has a trick, and there is a key to solve this problem. I want you guys to take, please, 10 minutes to think how to start with this problem, how to solve it. How can I find out what is the distance traveled by car A when they pass each other or when they intersect each other? Take 10 minutes. Take until, guys, 10:18, and then we're going to solve it together. Okay, so guys, in this example, we have to know what is the distance traveled by car A so that it will intersect car B, knowing that A starts from rest at t is equal to 0. What does this mean? So V0A is equal to 0. Travels along a straight road, which means this is a rectilinear motion with a constant acceleration 6, which means the first part of the motion for A is a uniformly accelerated motion until it reaches a speed of 80 feet per second, and then it will be a uniform motion, all right? So after reaching 80 feet per second, the motion will be uniform. And this means, guys, that at t is equal to 0, if I take my origin at A, at the first position of A, let's say this is my origin, and let's say this is S positive, okay? This is my axis. I should indicate my axis here. At t is equal to 0 here, V0 is equal to 0, and A is equal to 6, all right? And then, guys, A is equal to 6, and then at t prime, so we're gonna call this t prime, right? You are with me, guys? You're listening? All right, so at t prime, guys, V prime is equal to 80, and I don't know what is S prime here. So I don't know what is S prime here, but I know that after this t prime, the motion is uniform, all right? So the motion here is uniformly accelerated motion, and after t prime, the motion is uniform. And then, guys, B will start from 60 feet per second, and this is a constant speed motion, and will continue with the constant speed motion. So B, guys, will always have a uniform motion where V is equal to 60 feet per second. Now, another important note is that when t is equal to 0, car B is located to 6,000 feet. So what is this 6,000 feet, guys? Who can tell me what is this 6,000 feet? It's SB. SB only? It is S0B, right? So this is S0B, guys, because when t is equal to 0, the position of B is 6,000 feet. That's it. Okay? Now, guys, what is the key to solve this? Yes, Radwan, you're right. What is the key to solve this problem? How can I start? What is the key to solve this problem? So what is, guys, the key to solve this problem? Yes, perfect, Radwan. It is, guys, it is that SA is equal to SB at what? At the position of intersection. So guys, when they pass each other, the position of A, the position of A should be equal to the position of B, all right? And this position is from the same origin O. And I have, guys, to always stick to the same positive S direction, all right? يعني مش انه guys على البي اخذ S positive to the left وعلى A اخذ S positive to the right. No. It's all S is always positive to the right. The origin is always at A, so that when they pass each other, SA should be equal to SB. Now, I don't have any problem for SB because it is a uniform motion, all right? So I can directly apply the equation of uniform motion for the position, which is VBT plus S0B. So why can I apply this equation directly? Because both conditions are satisfied. The first condition is that this S0B, which is 6,000 feet, is at t is equal to 0. And the second condition is that B is always having a uniform motion, right? And this means, guys, that SB is equal to 60t or minus 60t. What do you think, guys? Is it 60 or minus 60t? Minus, of course, because S is positive to the right and 60 is negative, right? It's moving to the left, right? So I don't have any problem for SB. It is minus 60t plus 6,000. All right? Now, what about SA? What about SA? SA is divided into two parts. First of all, from when t is between 0 and t prime. This is what? This is a uniformly accelerated motion. And when t is greater than t prime until they pass each other, this is a uniform motion. So how can I find SA? How can I find SA? What do you think? For the first part, I can find directly S prime A. I can find directly, guys, S prime A. Alright, guys? I can find directly S prime A. How to find S prime A? First, I have to find T prime. How to find T prime? I know, guys, that at T prime, V prime is equal to 80. Yeah, so I can find T prime, guys. How? I can say that SA at this time interval is equal to half 80 squared. A is equal to 3 here, plus V0, T plus S0, so it is plus 0, right? Because V0 is equal to 0, it's starting from left, and S0 is equal to 0. And this is equal to 80 when T is equal to T prime. So I can find T prime, all right? Sorry, yes, A is equal to 6. 6 over 2 is a 3. All right, so T prime will be equal to what? What is T prime, guys? You can find T prime. I think I have here an error. I have T prime. I should find T prime. No, this is 80 is the velocity, guys. I should first find T prime from what? From the velocity. Okay, so I should use the equation of velocity. Okay. sorry guys. I should use the equation of velocity to find t prime, and then I can find s. So what is the equation of velocity in a uniformly accelerated motion? V prime, let's say, is equal to A, which is 6, t plus V0, which is 0 here, and this should be equal to 80. This will give me that t is equal to 8 over 6, which is 13.333. And this is t prime, of course. 33. Right? Now, I know t prime. I can replace it in the equation of SA prime, which is half 6 times 13.3 plus 0 plus 0. Right? All right, 13.3 squared, and this will be equal to 500. All right, 533 feet. All right. So this is SA prime. Now, when t is greater than t prime, I have a uniform motion. My question is, can I say that this SA here, since this is a uniform motion, can I say that this SA here is equal to ATT plus S0A, which is 0? Can I say that, guys? Why no? Because in fact, guys, this is not a uniform motion from t is equal to 0. All right? So it is not a uniform motion from t is equal to 0. What do I have to do a new interval, a new time interval? No, this will be confusing, Sana. What I can do is to repeat the integration. So I cannot use this equation. I can use this equation. ds is equal to at dt, right? And I can adjust for the boundary conditions to be between t prime now and t, not between t0, t is equal to 0 and t, because in fact this is not a uniform motion from t is equal to 0, and then this ds will be between s prime and s. And this means, guys, that s minus s prime will be equal to at t minus t prime. So did you recognize, guys, the difference between this correct equation and this incorrect equation? The difference, guys, is that here I have t minus t prime. And this means, guys, that SA will be equal to 80 t minus 13.3 bar plus S prime, which is 533. All right? So this is the equation of SA. Now that I know the equation of SA, I can equate these two s together. So here I'm going to write ATT minus 13.3 bar plus 533 feet is equal to minus 60t plus 6,000. Whenever I solve this equation, one unknown, it is the time. Whenever I know t, guys, I can find SA or SP, and they should be together. In fact, they will be equal. You can do it, guys. They will be equal to 3,201 feet. Right? And this time t, if you want the answer, it will be around 46.60 bars. All right? So guys, that's it. That's it. All right, so this is a good question. What if B reaches A before A moves uniform motion? Shouldn't we check this? Yes, of course, you can check this. In fact, you can check this easily because 46.6 is greater than 13.3. All right. Now, if you have a different answer, let's say you have an answer of that is less than t prime, then of course this means that they pass each other before reaching the uniform motion. But as long as this t 46.6 is greater than t prime, you are on the safe side. All right, Hassan? Good question.